Hello, guys. Welcome to Cheenta School of Statistics and Data Science. I'm extremely happy to welcome Shouhardyo Sarkar into this whole direction of sharing about his PSC project. The reason I like Shouhardyo is that he is very curious about his learning and work, and he is extremely passionate too, naturally, as an outcome. And I have gone through his BSc project. I really liked it. It's based on randomized technique, the response technique to estimate, secret questions that people don't tell everyone, um, like the answers to. So he has done a project and he has applied that. He has collected his own data set and applied that, uh, the technique, to his own collection of data. And I'm so happy to see his work. I wanted to share with you. Now I hand over the mic, the dais, to show the Sarkar so that he can continue his sharing about his work. And I will ask him frequent questions where I will not understand, and you have to explain me. Okay, Shouhardyo? Sounds good?
Yes, okay.
Very good. Welcome.
Uh, So let us start with the project. The main topic of my project is that the estimation of proportion of smokers and alcohol consumers by randomized response technique. So as we proceed, I am going to explain the project in detail. So let me go to the introduction part only. So let us begin. In sample surveys, what is the main problem in real life situation that whenever we try to estimate certain real life problems like which involve sensitive questions like do you consume alcohol, are you a smoker, are you a smoker, are you a drug addict, etc., which involve which are stigmatic in nature. In that case, we cannot use the normal procedure of direct question by framing a direct questionnaire and going house by house asking the question, because in that case the respondents will not give us the correct answer. They will give us probably a most biased answer, which because they are more aware of their personal securities and that their personal information may get leaked. In that case, to minimize the problem, Warner around 1969 developed the technique which was named as the randomized response technique, which involves a scientific uh, matter, which involves a scientific matter including probability and statistics, which enables the interviewer to collect the required and necessary data, uh, simultaneously ensuring the complete security of the respondent without revealing their any identity. So this is the main overview of the project.
Sure, though. Probably I forgot to mention that. Did I mention that you are from Maulana Azad College?
On
Probably
I
not. So yeah, Shouhardyo
I
is from
know.
Maulana Azad College. Yeah, so that's it. That's what I want to mention during that time. So yeah, so you will be working on this is very important. Like you can ask personal questions to people, and of course it will be biased as you have said.
Yes.
So do you want to talk about Warner's what he introduced, Warner's method of
Yes.
1965?
Now I am going to describe about the Warner's method. So it is before talking about Warner's method, let me give another thing of my project. My objective of the project was, and these are the 5 points that I listed, that to estimate the proportion of smokers in the science departments of Maulana Azad College of my college in third year. Next was to estimate the proportion of alcohol consumers in the science department of Maulana Azad College in third year. Now, to provide the mean and variance of the estimates obtained, to provide the maximum like to estimate, because in Warner's method we will sometimes encounter a situation when the estimates are not going to lie within the parameter space. We know that to be a perfect estimate, we have to the estimate should belong within the parameter space. In that case, we have to use maximum likely estimate. For example, the estimate can be negative. In that case, we have to take the estimate one. This case I will explain in detail in the later part.
Absolutely.
Uh, at last, I just suggested a combined or pooled estimate based on the weighted means of proportion of smokers and alcohol consumers of science department of third year students uh, by in by wait, just I think I did some. No, I suggest a combine a pool estimate based on the weighted means of all the third year students. Here I just use the treated each of the departments I as defined strata.
Okay,
Now,
okay,
now I'm just describing a oneness model. So oneness model is basically about, suppose we are interested in estimating a population proportion of a of a group of population who possesses a certain character, say it is A. Now the population is dichotomous. What is dichotomous? Means that the population, there are two kinds of people in the population who possess the character A, and another is
hmm,
the person who do not possess the character A. Means,
okay,
in my case, the character A is in oneness method is the proportion of smokers in Maulana Azad College. Another part of the population was the population who do not possess, who do not smoke, non-smokers. Since it is a stigmatic and, as I told earlier, stigmatic and sensitive nature, so we use the Warner's method. In Warner's method, what I did, I used a pack of 20 cards. Okay, so in a pack of
okay,
20 cards, in 12 cards, I wrote the question that, are you a smoker? And in 8
okay.
cards, I wrote the complement of the question, are you a non-smoker? Now, which means that I have known the population proportion. I have known the probability or the proportion, how many cards are proportion of smoker cards and non-smoker cards. For example, here it is the proportion of smoker cards or the probability of smoker cards is 12 by 20, and the complement is of course 8 by 20. This is needed in my survey.
So I didn't get you. You selected 12 by 12. Can you come again about that 12 and 8?
Okay, I used the randomization device with the help of pack of cards. I chose 20 pack of 20 cards. Now in 20 among the 20 cards, 12 cards consist of the question that, are you a smoker, and 8 cards consist of the question, are you a non-smoker.
Okay,
Uh, I chose this 12 and 8 because Warner suggested that it is preferable to keep the probability of p, which I am denoting as a probability that the proportion of number of cards containing the character A, means proportion of cards containing the question, the are you smoker, between 0.6 to 0.75. Yes, that is the reason I chose 12 and 8.
okay, got it. Okay.
Okay, so
So you have 20 cards and you randomly selected, like you kept 12 of them, which are smoker cards. 8 questions asked whether they're non-smoker, right?
yes.
Okay, okay. Then,
That is written here in the. So I interviewed these 7 departments: physics, mathematics, chemistry, botany, zoology, statistics, and
how did
sorry,
you conduct the survey?
microbiology.
Like, why I'm
Microbiology.
asking is because it can other students can actually understand how to do it.
Yes,
Yeah.
that is written, and I'm going to tell. So total number of students means my population size was 119, and I wanted to select a sample of size 50, including all the departments. So suppose now I went to the botany department. In botany department, there was around 10 students. Okay, now I use proportional allocation since I'm treating each of the department as strata. So I use proportional allocation to determine how many students I will select from each department. Suppose
Okay.
in botany department I have 10 students, but I don't need the 10 students. I need so how many students I need, that will be selected by means of proportional allocation.
Okay.
So now what I did, I numbered all the 10 students from by 2-digit random numbers from 00 to 09. Say now I
Oh, wait,
took
I didn't get you. Wait. So out of the 119 students in the science department, you're taking a sample of 50.
yes.
And where is the 10 coming from?
I'm just assuming. Suppose I went to to interview the botany department. Now in
Okay.
botany department, the strength of the students in the botany department is, suppose say 15, 10, 15, anything, just a number. Suppose it is 15. Okay. Now I do not need all the 15 students, because including all the departments, I need only 50 samples.
So you do
So,
50 into that 15 by 119.
no, means I not from each department I need 50.
No,
Include,
no. You say the proportion, like you need 50 out of 190, that proportion. So let's
yes,
say,
yes.
into number of students of that class, of that
Yes,
department, right?
yes, that is the proportional allocation. Yes,
Yeah, absolutely. Yeah.
yes, that is the proportional allocation I did. Suppose out of 15 students, by means of proportional allocation, it turned out that I had to select 8 students.
Yeah.
Suppose. Now what I did, I numbered all the 15 students by two-digit random number starting from 00 to 014.
Okay.
Sorry, not 00 to 14. Okay. Now I opened the random number table, took a two-digit random number, and no, before that I found out the greatest multiple of two-digit number 15, like 15 into 6, 90, which is two-digit number,
Okay.
and 15 into 7, which is the largest two-digit multiple of 15. Since I am assuming that there are 15 students in the botany department.
Okay.
Now I am drawing the two-digit random number. If the random numbers that I draw lies between 0 and 15, then I am suppose it is 0 and the random number drawn is 5. So I am select the person whom I have numbered fifth.
Okay.
But if the number drawn is greater than 90, or number drawn is greater than 90, I am rejecting that random number and drawing another random number. But if the number drawn is between 50 and 19, what I am doing, I am dividing it by 15, suppose 35. Now I am dividing it by 15, I am getting the remainder as, I think, 5. So again, I am taking the person who is numbered as 5 as
What
into
is
my
this?
sample.
What is this called? What is this format of sampling called?
It is a normal method of sampling by using the random number table.
So
Uh,
I have a question. So you have done the good work using random number table, but why didn't you use R to generate random numbers and select those?
I wanted to do it in my means of hand, means primary data. I was collecting the primary data.
Okay, got it. Okay,
So,
fine.
and in R, we need, it is important that in R, if we have to draw a lot of random numbers, here my sample size is comparatively very small. That's why I prefer to do it by
So
just seeing
what
the
I
random
mean is
number
that
table.
let's say 15 people, you number them 1 to 15, okay, and from
Yes,
R you select sample 8 comma 15, right? It will
yes,
give.
actually, I was not much accustomed by using R and generating the
It's okay,
random
no
number.
worries. I just told you
That's
that
why.
this could have been done
Yes,
that way.
yes,
This
yes,
this way.
yes.
Yeah. I mean, it
So
could have
this
saved
was,
your time. Yeah.
yes, this was my procedure of collecting data. This I continued for the 7 departments and
Mm-hmm.
collected a sample of size 50.
Mm-hmm.
Now what I did, okay, wait. Now what I did, again I'm taking the example of botany department only. Suppose the person selected, all 8 of the persons have been selected by means of proportional allocation. Now I gave them all the 8 cards. I let them
Okay.
choose any 8 cards out of the 20 cards without showing me whatever
Okay.
cards are I. So they chose 8 cards. Now in the 8 cards, there were 2 kinds of question, as I told previously, that
So
are
out
you a
of those
smoker?
12, 20 cards, they're selecting 8 cards.
Yes, yes. How many
Okay.
number of people who are selected by proportional allocations? Here I
So
am
you
supposing.
I'm trying to understand, you went to them to with a box, and in that from that box they picked out a card.
Yes, I took a I went with a pack of 20 cards, and after uh, selecting by proportional allocation and this random number procedure, suppose 8% came up. Then I
Hmm.
told them to choose any 8 cards from the pack of 20 cards.
Got it. Yeah. Very good. Okay.
He took
Then.
20 cards. Now the cards consist of 2 questions. Are you
Mm-hmm.
smoker, non-smoker? They just provided me with the answer yes and no. So I am not aware of what the 8% are having the question in their card. Some may have the question, are you a non-smoker, and some may have the question, are you a smoker. They are just giving me the answer that yes or no. So I am not able to know on which question they are giving the answer. So as a result, their identity and their choice are fully secure. This is the main process of
Absolutely.
Warner's method.
Yes.
So
Yes.
and my aim was to just to collect yes and no yes responses, and
Mm-hmm.
then we have a formula which was developed by Warner's. Let me go to the formula. All this thing is in detail has been explained in this project, this theoretical part. Yes. Now, this was the formula by which we can provide an estimate of, by this pi hat w, provide an estimate of number of proportion of smokers in the botany department. R is
Okay.
the number
Let's
of,
understand. What is
yes.
this n?
N is the sample size, means
That
the
in this
by
case it is
proportional.
8.
Yes, in this case it is it.
What is r?
R is the number of yes responses that I have obtained.
Okay.
P is the that probability 12 by 20 proportional smoker cards.
Okay.
So
Interesting.
just
Wait,
the
wait. Stay there.
mhm,
Stay there.
okay.
So, how did you exactly model this? Can you just explain a bit of it? Because I think, I mean, people will learn a bit of probability from here. Yeah. Just like scroll through the idea.
Which one? This pi at the,
How it can be reached to this whole thing? I think it's based on conditional probability, right?
yes, it is based on conditional probability, but the derivation to arrive is, it's a bit complicated actually.
Okay. 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 Got it. Okay.
So means for
What is this
BSc it
lambda?
was out of syllabus actually. Okay, lambda was the actual proportion of smokers in population corresponding to each strata. So we are estimating lambda by r by n.
Okay. Got it. Got it. Okay. Perfect. And since R follows a binomial distribution, what
Yes,
is
r always
the
binomial distribution.
response
I'm
also? N is number of sample. Lambda is the
proportion of smokers,
yeah.
smoker
So of
cards.
course, yeah, yeah. R follows binomial R n comma lambda.
Yes.
You're right.
So I'm getting the variance of my estimator pi hat w for each of the department. This is the estimate of variance that I can obtain.
Okay, can you just go above? So in this pi hat, R is a random variable. Rest are all constants, right?
Yes, r is only the random variable.
And hence R follows binomials. So
Yes,
that's the way it finds out.
yes.
Okay. So
Because
if
the r is the one which I am getting by using random number of yes responses. So it is obviously a random variable.
got it. Okay. Can you go ahead? So you have found out the unbiased estimator.
Unbiased estimator and the estimate of the variance.
Mm-hmm.
Uh, now there is another thing which
Yeah,
I need
this
to say.
I find a really interesting concept. Can you go above? So it's saying that can you go to the variance thing? So it's saying the variance is, can you go, above? Yeah, the variance. So you see the variance is minimum when P is equal to 1 or 0, right?
Yes, that was the thing I was going to explain.
Okay.
So suppose P is 1, which means that first question, what was my first question? That are you a smoker? So if P once means that the it is a sure event that the person is selecting the first question. In
Okay.
that case, the I am in that case, the security of the person is completely disrupted, because I know that the person is selecting will be selecting that the first question only, and as a result, his answer yes and no, the complete procedure will be biased. So in that case, the
You're
variance
right.
will be minimum. In that case, there will be no variance actually. For when P
Yeah.
will be 1 or
No, the
P equal to
variance will
0.
come from the stratification. Like,
Yes.
yeah.
So, but if P is close to half, in that case, it is an ideal situation that the respondent is assured that his identity will not be revealed, because it is a 50-50 chance that I do not know whatever card he or she is choosing. But the problem is the variance and the efficiency and the concept of securing the identity and the information of the respondent is a conflicting thing. Means
Mm.
if I go to secure the information and the all the sensitive informations of the respondent, the variance becomes uh, the variance increases. But
Yeah.
if my tendency, as a result, the efficiency decreases. On the
True.
other hand, if my aim is to decrease the variance, In that case, the proposition of providing the security to the respondent becomes less. In that case, my efficiency increases, but that survey becomes a little bit biased.
So how do you compare the efficiency?
Efficiency means, suppose when the variance is, when p equals to 1, in that case variance is minimum.
Yeah.
But for p equals to 1, the whole procedure of collecting the data becomes a bit biased, because as I told previously that in that
So
case
how do you
I
measure
know
it?
which one.
So this biasness.
Biasness, when p equals to 1, I know that the respondent will select the question which is the first question only. Are you smoker? Because p equals to 1, the respondent will select the first question with probability 1. So I
Okay.
know that the respondent has chosen this question. As a result, if the respondent says yes or no, I am knowing that he is a non-smoker, he is a smoker, and he is saying yes. So the concept of randomized response technique is getting disrupted, because the concept says that the interviewer should not know which kind of card the respondent is choosing. In this,
Correct.
so in this case, variance is minimum, but my concept of randomized response technique is getting disrupted. As a result, variance minimum means efficiency is better. So it is a conflicting thing between the efficiency and securing the informations of the respondents. So this is just a fact uh,
This is
in this
interesting.
in this
I'm just thinking
randomized
about
response.
this fact that how to mathematically find this 0.60, 0.75, like.
What I thought that 0.6, 0.75 is just close to half. In 0.6 is very close to half. If I think 0.6, um, uh, I think 0.6 will be ideal. In that case, I have a 50-50 chance of knowing that the person, whatever the means, which question is the respondent is selecting. So it ensures a much more privacy to the respondent. In that case, I think they have said that p between 0.6 to 0.7 would be recommendable. I am not aware of the exact mathematical derivation, but what I thought was that only that value of probability p close to half would be better to ensure the privacy of to the respondent.
So this is how you selected 8, 12 out of 20, right?
Yes, because 12 by 20 means 0.6, I think. Oh, that is correct.
So now what I'm thinking is that why not the other way around? Because I think, can you go to the variance thing? Yeah. So see, observe that yeah, this is symmetric in P, the variance.
Yes, of course. Fine. Yes.
So P into 1 minus P into N into 2P minus 1 whole square. Right? It's symmetric in P. If you select,
Yes.
no, probably not. I'm wrong. Symmetric around half, not 0. Yeah, symmetric around half. That's what I mean.
Yes.
Right? It's symmetric
Yes.
around half. You can prove that it's symmetric around half. Okay.
Yes.
So my question is this, that if P was 0.6, it's a good. Why not 0.4 with symmetric around half?
Okay. I got
So this
you.
was my question, that since it's symmetric in P, so if P is selected to be 0.6 or 0.75, there's something going on, like more than just the minimizing the variance. That's my question is. So maybe students out there or you can think about it, like why P is just. Did you understand the question, Shouhardyo?
Yes. 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 I got the question.
So that's the question, like why just like, because I understand like the symmetric to P symmetric means like
Yes.
the randomness will be the same, the deviation will be the same, right? So it's like P is selected to be 0.6 just because both of them works, like it's just randomly selected to be just P greater than 0.6, or it's just like This is the
what
mathematics behind it.
what I read that, and they consider it from practical situations. So I don't think they have any logical explanation behind this. See,
Mhm. You're right.
from practical consideration, I think they have chosen zero point 0.6 and 0.7. But in the previously in the theory, they have written that any value, see if, this line, they have said that any value close to half will be good. But from practical situation, they have taken 0.6.
Okay.
Oh, I think the reason, because yes, I remember the reason. From practical situation, when, because I thought of that and I took p to be 0.4 in once. I was getting the estimates mainly on negative. In most of the case, the estimates are going to like pi half w was negative
Can you show the the
formula.
which estimate?
This one, pi hat w.
Oh yeah. Oh yes, you're right. Because
Below, yes,
yeah, p should be, no, wait. So okay, you're right. So let me just think. 2p
if
minus
you
1 n common, so p minus 1 into n plus rn.
I, I think I'm getting negative.
Yeah. So if let's say p is 0.4,
So 2 into 0.3. This part is becoming negative, I guess. Sorry. 2p minus 1 is negative.
p minus 1 is
No.
also negative, right?
Oh, yes. P minus 1. Again, no, okay. This portion was getting the problem. This portion, the denominator is becoming negative, and as a result, the whole part was greater than this one, p minus 1 by 2p minus 1. As a result, pi hat w was coming
Okay,
less
okay.
than 0.
Okay, let's understand this. So if pi hat w should be greater than 0, that means p minus 1, or let's say 1, okay, p minus 1 by 2p minus 1 should be greater than r into 2p minus 1 minus will go to that side.
Yes.
So 1 minus p by 1 minus 2p should be greater than r by 1 minus
R by
2p into
1
n.
minus. Hmm.
So 1 minus 2p is, if 1 minus 2p is,
There is the problem of half is coming. If 1 minus 2p is
if it's greater than 0, then the inequality
so
will, so let me try it out.
p greater than half.
You can try it on your own copy.
1 minus
That
2p is greater than 0. P is less than half. For 1 minus 2p is greater than 0 means
yeah.
p is less than half.
So it
In that,
stands on 1 minus 2p into 1 minus p by 1 minus 2p is greater than r by n times 1 minus 2p. So if 1 minus 2p is greater than 0, it turns out that 1 minus p is greater than r by
yes.
n. If 1 minus 2p is less than 0, it turns out 1 minus p is less than r by n. That
Yes.
means here it implies that p is less than 1 minus r by n. And here
Yes.
it implies that p is greater than 1 minus r by n. So r is what?
R is the number of yes responses.
So, so if capital P is greater than half,
In that case, I think pi hat w is coming positive. If I
see, it's coming out that if P is less than half, like there are two cases coming up. Okay. If P is less than half, capital P, for pi hat to be greater than 0, P must be also less than 1 minus Rn.
yes,
If P is greater than half, for
for
pi,
that for that problem, we have to introduce the maximum likelihood estimates for the two cases, which I have
yeah,
done.
you're right.
Yeah, I can show you that this first is this is the maximum likelihood estimates. There are two situations when
Okay, so okay, understood. So can we go step by step? Otherwise, people can get confused. Yeah. So
Yes, the next step was only this maximum
okay,
likelihood
yeah.
estimate.
So now you're estimating the models of the parameters. What are the parameters here?
Here the parameters is R. Sorry, yes, R. No, no, R, not R, sorry. Pi at W. I'm not estimating it. I'm estimating giving a maximum likelihood estimate of pi at W only. That is the parameter. Because as you said, people, there are two cases that p greater than half and p less than half.
Yes.
So this is the case for p greater than half. This is lambda hat.
So lambda is the parameter.
Lambda is a parameter.
What is the
Then
what was lambda? I forgot.
lambda was our proportion of
Smokers.
smokers.
That's what we want. Yeah. So how
Yes.
did you do the maximum likelihood estimator? Can you show us?
Okay.
So you lambda. Okay, lambda. Yeah, lambda. How did you do?
Just
Okay.
why
Yeah,
we
because
can
R
drop
follows
that.
binomial
Yes.
n comma lambda. And likelihood of pi is what is pi?
Pi is the proportion of smokers. Pi hat W means this one. So pi hat W.
Yeah.
That is the one I'm going to estimate. Pi hat W. For that, I have to provide an estimate of lambda hat.
Yes. Please go
Uh,
ahead.
uh, there are two cases, as you told, just that p greater than half, p and p less than half. For p greater than half, this is our maximum likelihood estimate. That lambda hat equal to 1 minus p r by n means number of yes obtained, yes responses obtained by sample size is less than equal to 1 minus p. R by n equals this one, and p is if r by n greater than p.
Mm-hmm.
And this is the estimate for if p is less than half. I think Sujita, this was the problem you were talking about previously. That there are two cases: p greater than half, p less than half. I guess.
Yeah. No, but I was thinking like, what are the conditions on P that makes pi hat lambda greater than zero? That was my question, and I got that these numbers from there only, not like from the MLE thing. But it turns out to be the same. Like it's coming from the same thing. So probably it
I think
considers.
I think the conditions is that p has to be greater than half. I think
Okay. Okay.
because
Okay.
in practically I face that problem. That's why I'm just asking you.
The true MLE of pi is when P is greater than half. Yeah, I think one can prove that like this MLE. Okay. Yeah. Yeah, one any student interested in this can go and check his work out there. You can get in touch with Shouhardyo. I will give his LinkedIn link over here. His so you can get in touch with him on LinkedIn. Yes.
Now another thing that Warner statistic has a drawback, which says that Warner statistic, which is R, is not sufficient for pi unless p equal to 1.
Okay.
So it can be proved. And this is the Fisher's information loss, the information loss of information.
Unless P
So
is equal to half or
yes,
one.
unless half or one, or 1, sorry, unless p equal
Using
to 1.
Fisher's method of information, calculate the amount of information. Okay.
So as a result, there is another in around 1969, Greenberg developed another method of randomized response technique, which is wholly close to Warner's method, but the framing of question is a bit different. So let us proceed there, which is the unrelated question model. So what we do in unrelated question model, the it is completely similar to Warner's model, but here question in Warner's model I used two questions, which was one was the complement of other. Suppose are you a
Mhm.
smoker? Another was are you a non-smoker? But in unrelated question model, and the question framing will be of this kind that do you consume alcohol? One question, and the next question will be completely unrelated. Is your birthday in the month of February, or is your birthday in the month of June, or any other unrelated question?
Okay.
And the rest are same, simply. Because I think this procedure ensures a much more security to the respondents. compared to the Warner's method.
Yeah.
The
Then
whole
what did you get?
So the whole randomization, everything was same. That here the difference was that here similarly I took 20 a pack of 20 cards. In 12 cards, I wrote the question: Are you a alcohol? Do you consume alcohol? And in 8 cards, I wrote the unrelated question: Is your birthday in the month of February?
Okay, okay.
Now here two another here extra
So did the
situation arises that
participants know that?
yes, the persons were aware of both the processes.
Okay, okay.
But now here a second problem arises that here pi y I define here pi y, which is a true proportion of individuals belonging to group y. Here group y means the unrelated group, means I have to estimate that how many peoples in the, suppose I am again taking the example of botany department, how many peoples in the botany department uh, are born in the month of February.
So you assume it's uniform?
Yes, no, not uniform. I have uh, collected independently from direct question. Means I went to botany department. First, I asked every one of them how many of you are born in the month of um, February.
Okay.
I did not went to there. There can be two cases. One is pi y is not known. In that case, I have to estimate pi y. It is bit complex. In that case, another case is that I have to by direct question I am getting the estimate of pi y, which I did in my project.
Got it. So you went and asked Charlie what is
Yes,
their distribution, and then use that pi y hat as a value in the actual model.
yes.
Okay.
So the process is same, just like previous oneness models. Same allocation by a random number and proportional allocation.
Okay.
So, but now the what is different is in the estimator.
Yeah.
In oneness method, we had pi hat w. Here we are getting this one,
Okay.
where R is the number of yes responses that I have obtained. N is the sample size that I have collected by means of proportional allocation. P is the probability of number of cards consisting of the question, do you consume alcohol, which is 12 by 20. And pi y is the proportion of persons whose uh, birthday is in the month of February.
Okay.
So again, the estimate of variance is given by this one. So as I told, there are two cases. Pi y is unknown. In that case, I have to estimate pi y. But since I'm not talking about that because I haven't done. Uh, yes, sorry, I have done this one. Pi y is unknown. So in that case, the variance of I hat u2
Mm-hmm.
becomes this one.
What is
This
you
one.
do? I forgot.
U2 is that one only proportion of alcohol consumers, which I want to estimate of Maulana
Okay.
Azad College
Okay.
from every department. Now there is a restriction that to increase the efficiency of the estimator of pi hat u2, one has to choose the design parameters n1 into p1 p2 optimally. In practice, the size of the sample will be remain fixed, as we know. So we have to minimize the variance subject to the restriction n equal to n1 plus n2.
Okay.
So as a result, we get the modified variance of our estimator. This is the optimal solution of n1 and n2 we are
Mm-hmm.
getting. So the optimal value of the variance becomes this one.
Okay.
It is a bit difficult as compared to Warner's method because
I
of the main
understand.
fact that we are estimating pi y here.
Yeah, I mean, I
Means
think it's a really good exercise for the students who are watching this to go and visit his work and understand the proof in details and read the papers. Like if you can, that can be a really good addition to your understanding. Yes. Then.
then if now I'm coming to the data which I have collected. It is very interesting part because in most of my friends what they did, they collected secondary data. So I was the one person who collected primary data. Most of
Great.
them are collected data from the websites Kaggle, and there are several other websites. So I always wanted to collect primary data. So whenever from the day I read sample survey. So this was my method. There were 12 cards and 8 cards. Probability was 0.6 as I told. Now this is the complete data which I have collected. This one.
Mhm.
From botany students, the total number of students were n. By proportional allocation, it turned out to be that I have to select 3 students.
Hmm.
Number of yes responses I in Warner's method in estimating proportion of smokers was 1, and in estimating proportion of alcohol consumer by means of unrelated question method was 1. So this is the complete data set of all the 7 departments which I interviewed.
Interesting. Can you go below? What did you get?
Going there. Now just data analysis part. Okay, just explain the notations again. Here pi hat WH means the proportion of smokers in the H8 department, or I'm treating each department as strata. H is equal to 1 to 7. So for each of the department, we are calculating this estimate proportion of smokers, their variance. Then again, pi hat U1H is the proportion of alcohol consumers for the H8 department.
Mm-hmm.
Uh, and pi hat YH is R2H by N, where R2H is the number of individuals in the samples obtained from the H8 department who are born in the month of February, which
Okay.
I think previously. Now I told that pi hat pi h were independently estimated from direct question for each of the department. Then the variance is this one. NH is the size of the sample selected by proportional allocation. RSH is the number of yes responses that I obtained from H8 department in Warner's method, and RH is the number of yes responses that I obtained from the H8 department by using the unrelated question method.
Okay.
Now, the analysis part, main part. Department of Botany,
So yeah,
size
I
of
mean,
the
I think you can call put in all the what did you get the results? So you did for all the departments.
okay. Shall I
Yeah, I
go
mean because
just to
it's
the
just
result?
applying the results here, right?
Yes. Okay. Then it's better I can show the bar graph. There I can explain it. This is simply the calculation part only here. If I go to the bar graph. Okay. For botany department, proportion of smokers turns out to be 0,
Mm-hmm.
and proportion of alcohol consumer turned out to be 0.12. For chemistry was the only department where both of the proportion was 0.
That's great.
Microbiology for proportion of smoker was zero point 0.5 and alcohol was 0.62. Zoology was 0.85 and zero point 0.05. For physics, 0 and 0.02. For statistics, zero point 0.5 and 0.61. And last for mathematics was zero point 0.2 and 0.42. Now, when I plotted this one, whole results, it turns out that zoology department was the department which had the highest proportion of smokers, followed by microbiology, and physics, chemistry, and botany were the departments where there were no smokers.
Very good.
So this thing was completely based on Warner's model by the estimation of proportion of
Mm-hmm.
smokers. Now the proportion of alcohol consumers, which I estimated by means of that unrelated question method, here it turns out that microbiology
So
was a department.
the previous one was with Warner's model.
Yes, previous one was based on Warner's model. This is the
You didn't use
alcohol.
the unrelated question method for the previous
No,
one.
no, no, no.
Okay.
Now for
Because
microbiology
it would have
department,
been great because no,
yes,
how
it
can
would have.
you do the same thing?
I had to collect another data again.
Got it. Okay.
It took huge time, huge amount of time actually.
Yeah, got it. Got it. It takes time. Yeah, I can understand.
And so in for alcohol case, microbiology department had the highest alcohol consumers, and chemistry department had no alcohol consumers. So what was the inference that chemistry department was the most so-called what we say that good department. It had no alcohol consumer or smokers. So my last part was that I tried to propose a combined estimator by my own, which was based on this statistic E, which is equal to summation sub WHPH, where WH is NH by N. What is NH? Capital NH is the total size of the department. Means in botany department, the total strength of the student was 7. So NH
Mhm.
is 7 and N is the total population size, which is capital, which is 119.
Mhm.
And pH is the proportion of smokers or alcohol consumers that we have obtained for each of the department, HH department.
Yeah.
Similarly, calculated the variance.
It's just
Uh,
average of like the,
yes,
weighted average of the
yes,
probabilities.
yes. So now it is done by this is simple calculation.
Okay. Yeah.
This now for alcohol consumer the same thing. Their variance is this one. So what I obtained is that combined estimate of proportion of smokers and alcohol consumers of the third year students of science departments of Maulana Azad College is around 0.36 and 0.25. That is about 36% and 25%.
Interesting. Um. Yeah. It's fine. Yeah.
This
Perfect.
was
Really great
all
work.
about.
What do you think? A student, a BSc student, can enhance or can work similar in similar directions. What do you think you could have done, but you couldn't do?
One of the thing was that I wanted to do compare the unrelated question method and Warner's method for simultaneously. That you said that for Warner's model, I did only for the estimating the proportion of smokers, I did only the Warner's method. I would like to use the unrelated question method and wanted to see the difference, which one is better. As we are claiming that the unrelated question method is better, it can be shown much, it can be checked if we use. And second thing which I tried to do, which I tried to prove but couldn't, that we know that if we do stratification,
Yeah.
uh, the variance decreases than simple random sampling.
What decreases?
The variance,
Variance. Sorry.
means that for stratification, the efficiency increases as compared to simple random sample. Correct.
Yeah.
So here I am treating each of the department as a strata, which means I am doing stratification. So I wanted to show that the if I conducted the same experiment by a simple without doing the stratifications, means it would have required a lot of time if I again went to collect data and just do it by simple random sampling, simple without replacement. Then the variance that I will obtain in that case and the variance which I have obtained here is, if we compare, the variance for stratification would be lesser. This thing I wanted to show theoretically, but I couldn't prove.
Okay, so this can be really good work for
Yes,
like the students, like comparison the variance of the stratified method and the simple random sampling method. But can you one can also prove it like using like simulation, like using data. One can also prove it like that. So one can be about the
yes,
variance comparison of the stratification and the simple random sampling of the same thing. I mean, also like one can just use this similar idea to do on his or her own college. Okay, and another thing is comparing the unquestion like unrelated
And
question method.
another thing I wanted to do, I mainly worked with the science department. It would have been better if I could compare with the arts departments, but I couldn't do because of time restriction.
Yeah, I
So
think one good way to use time is using Google form and use the whole random sampling process.
in
uh,
if I use Google form, how can I ensure security to the respondent? That means how can I conduct the randomized response technique?
because I mean you will not take in any name or you will just take anonymous votes. Essentially it's after all seeing the average, right, or total number. So you just take
Uh,
in the votes.
Number of yes responses, yes.
Yes. So just taking the votes, like you just don't see the name, like you don't collect the names. You like you just don't collect the names. Like you assign, like if you know the people, you assign by the roll number and randomly select the roll numbers by you use that previous random
Random
allocation.
number table, yes,
Yeah.
random allocation.
And then go on to this individual people and give them the form for quick
Actually, I
exit.
was not aware that in Google form, how can I collect data by not showing their name? I do not know that.
Yeah, it's okay,
That's
it's okay. But you can also use like some other anonymous form collection method.
yes.
Yeah.
Lot of randomized device can be used here. Not
Yeah.
I use
So
this
that can be
much
another
of
way to do it quickly, because by doing it quickly, you can do more such analysis, like comparison analysis,
yes,
right?
yes.
Yeah. So that can be one way to for the other BSc students who are aiming for, like, or interested in this project. So thank you, Shouhardyo, once again for coming, and thank you for your beautiful project and your passionate work that you have done here. um, I will link your connect, or your contact in the description below in of YouTube, so that people can get in touch with you. And I will be happy if you can share a bit of your time to the students, by when they have doubts regarding the project or what ideas they can implement. Okay.
Yes, yes, of course.
So yeah, Shod is a really passionate guy. I really like to work with him and and talk to him. So all the best, Shod, though. Thank you guys for staying tuned. I will see you in the next video. I hope you're enjoying the BSc project discussion and getting ideas. So thank you again. Bye bye.